a technical gift for our amusement from Vince the crew chief, and I think he got this in Singapore for 12.9 Singaporean dollars, I'm guessing. Standing camping light with fan from Cash Converters. Okay, so I have looked online, and unfortunately it is available on eBay and it's available in pink, but that's okay. It just makes me feel guilty because Vince probably added this to his luggage and brought it back, and it would have taken quite a bit of space. The box itself is quite big. And, well, let's look at the features. It's got a fan in it, and this is probably going to try not to blow it at the microphone, but it's got a knob here. It starts off full, and then as you turn it down or up, it reduces the speed. I'm guessing it starts at full initially just because that's to give it a kick start and get it running. This grill is very slightly movable. It's got a flashlight on the side, which you can turn on by clicking that way, and it's quite bright, it's useful. Looks like a 1 watt bead, as the Chinese tend to call them. And then there's a work light at the top. You click it the other way, and it's got a sort of a wash of light comes out this panel with a matrix of surface mount LEDs. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30 LEDs. For charging, it's got the option of a solar panel. The solar panel does actually look capable. It looks chunky. I would say maybe a couple hundred milliamps, possibly. Maybe just 100 milliamps. But it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections, each giving out half a volt, which means it's going to be rated for about 6 volts for the rechargeable battery, which at this point I'm guessing is not nickel metal hydride, could be nickel metal hydride given the sort of pedigree of this, but I'm hoping it's lithium. Does it say lithium? Is there anything on this? It didn't say anything in the box. So it's got a handle that folds up. It's got a charging port. Now notice that the red LED is lit at the moment. That's just purely the light hitting the solar panel. It is quite sensitive. The figure 8 lead it comes with is the one that starts to give clues as to its pedigree here. It's got a very small figure 8 lead that goes into what looks like a standard figure 8 sort of socket. And if I plug it in with my recently bought Poundland adapter, if I plug it in, the red LED lights fairly brightly and it takes a charge. Not sure how much charging current it is. I've not got the stuff to actually test that with. Not here anyway. It does allude to the technology because it says, where does it say it? Please connect to a 20 volt socket, charge solar battery, the charger get hot. Please do not use when charging in order to avoid electric shock. And this makes me think of the Death Daleks, the capacitive dropper charger flashlights that are available that also have this sort of token gesture solar panel. This one seems like a proper unit. But what this lacks is the USB output, which is good because it was USB outlet and other ones that made them pose a sort of hazard. So let's take it to bits. That's what we do. So I can see a couple of screw positions here. I can see a couple of screws here. And a couple of screws underneath along with some feet. Okay, let's just take all the screws out. That seems like a good idea. I'm not sure if this is going to be one of these things that... Does this unscrew? Yes, it does. Ugh. Oh. Ooh, I can see the circuit board. I can see the battery. That looks like one of those sealed lead acid batteries in there. Let's get a wee bit closer to that. Do you see that in there? Okay, let's continue taking screws out. This is quite nice, this assembly. It's quite common in these lights that you've got the 1 watt LED on an aluminium heatsink that then screws onto the back of a reflector. It's quite a nice idea. I'm not sure how long the unit runs. They claim quite a long run time on a full charge. Certainly the fan, we had it running one evening with the fan because it was a rather hot day and it did pretty well. A couple more screws to take out here. Gonna have to be careful not to short anything out. This is a student accommodation I'm in at the moment for work while the students are away on holiday. And It's got sensitive smoke detectors, which is not good. Oh, does this thing have to come off? Oh, right. I think that's how it comes apart. Are there any more screws that I don't know about? Yes, there is. I didn't take one of the screws out. That'll be why it's not coming apart. Okay. Rightio, it is a capacitive dropper. It's got quite a big battery in there. Oh, these unplug. That's quite nice. So I can unplug that and put it away. We get the fan motor coming down. Everything plugs in, that's nice. And it's got a transistor for the motor, so it's varying probably the current drive to. I doubt it'd be pulse width modulating it. It will just be varying the bias to the base or gate, depending on what it is. Right, so let's take a closer look at this actually. You know what, I should reverse engineer it first, but let's take a look into here. So what I'm seeing here is the classic big capacitor here. I'm seeing two bridge rectifiers. What's that about? There's a big battery in the back. The multi-way switch, which has a couple of resistors. I'm guessing since this is doing the LEDs, that one resistor will be for the LED torch, the flashlight, and one maybe for the other panel. Well, there's the two connectors right next to it. Right, one moment please. I'm going to whip this circuit board out and we shall reverse engineer it. I will not lie, that took me quite a time to reverse engineer because there's a bridge rectifier composed of 4 diodes here, and then there's 4 other diodes, each with a separate function, and tracing it out was actually quite complex. So let's follow it out. And I've split it into 2 sections because it makes more sense that way. So the first is the battery charger, and it charges the battery at 100 milliamps approximately. So we've got the incoming supply, the AC supply, which is designed for 220 volts but works at 240 and would work at 120 volts. It comes in via this capacitor, and the capacitor allows a portion of current through in each half wave. There's a discharge resistor across that to stop people from getting a bit of a zing if they pull this plug out and then touch the pins. It just makes sure that gets discharged. If anything, I'd like to have seen that little bit higher value, like 470k. So that then comes to the bridge rectifier, and I'll come down to this LED in a moment. This is the charging LED. So it goes through the bridge rectifier, full bridge rectifier, gets smoothed by this electrolytic capacitor, 220 microfarad, 35 volts, and then charges this, what I guess is a sealed lead acid battery here, but there's a diode from the battery's negative connection down to the negative from the bridge rectifier and capacitor, and that's for a very specific reason. The voltage, because it's charging that battery, is kind of capped to about 4 volts plus the drop across the bridge rectifier, maybe a couple of volts. So the voltage here is approximately, it's half wave, but it's going to light this LED, but it will be limited to about 6 volts. So that LED glows dimly when it's charging and has a visible flicker because it is only lighting each half wave. The battery can also be charged from this solar panel, and it does so via this diode here. That's one of the extra diodes, as is this. And another diode is used from the solar panel going right across. It's used to block current flow from that side, but also to allow the solar panel to actually light the LED too. And let me think, the other diode in the circuit is used for the fan disable. I didn't realize it had this function. When you've got it in charge, because the fan draws quite a lot of current, it turns the fan off. And that sums up the charging circuit. So I'll just pause momentarily if you want to freeze frame and explore that bit of circuitry. And then we'll go on to the next bit of circuitry, which is, now before I turn over, keep in mind that when the fan unit is charging, fan disable gets pulled effectively negative with respect to the 0 volt rail. The LEDs in the fan, I shall just nudge that up till everything fits in. That's about it there. Let's start with LEDs because they're easiest. It goes from the positive 4-volt rail via this switch, and the switch has 3 positions, middle is off, either side is via a 4.7 ohm resistor. Although there are two 4.7 ohm resistors, the current is slightly different. You've got the spot LED, which is a typical 1 watt chip, and it's running at 170 milliamps. The other one goes to the parallel array of 30 surface mount LEDs, and it goes through the same value resistor, and it passes 215 milliamps because these LEDs are being run quite low, so their forward voltage will be a tiny bit lower, whereas this one's being run at about effectively half a watt, so its voltage will be slightly higher, so that explains the difference in the current. The fan circuit is the most complicated bit here. We've got the rotary switch with the potentiometer here, and when you turn it on, it makes circuit it powers the fan, which is then controlled by this transistor down here, which is operated in what they call its linear region. They're basically varying the base current to this transistor, which then regulates the current flowing through the fan. It means that this is acting like a resistor, so it will dissipate a bit of heat. The potentiometer also has this variable resistor section as well as that switch, and that forms a potential divider with this 1K5 resistor. And then there's another 2 resistors, one coming from the tap there and one coming from the wiper arm through this 1.2K resistor. And I'm reckoning that they've balanced the values here so that if you were to put this wiper right up to the 4-volt rail, it would not limit the current. So this 1.2K resistor is to limit the current to the maximum current into the base, and that will also set the maximum speed. That's probably the transistor turned fully on. This 330 ohm resistor, I think, is to nudge the value of current flowing into the transistor to sort of give it an absolute minimum value. So when you turn it down to the lowest setting, it won't just turn off completely. It will always keep running at that speed just to make sure that the fan keeps turning. And that's fundamentally it. It's the potentiometer and 3 other resistors to set that sort of variable range. The fan disable here is the one that is in the previous page that pulls to just below negative. Basically speaking, it turns this transistor off completely by shunting the gate current. And I can prove that. Let's zoom out here. Let's bring the circuit board in. Let's plug the mains into it. It's not plugged in yet. I shall move this out of the way. Tell you what, I'm just going to zoom back in this because what I didn't do there was let you guys take a wee snapshot of this if you want to freeze frame and take a look at the circuitry. So now I'll zoom back out again. And I'll show you that function where it turns the fan off if I can find. So I'll plug this into here. I won't plug it in yet. Let's plug the battery in, making sure I get it into the right connection. And we'll plug the fan in. Technically speaking, I'd probably plug the LEDs in and shown it visually, but let's do it with the fan. Let's make lots of fan noise in the microphone. So now, if I bring this in, if I plug this in but don't turn it on at the wall, so it's not charging, and I turn this round, and I turn the fan down to a low speed where it's probably not making microphony hissing, whooshing air noises, so it's rattling about. If I now charge this by turning it on, it turns the fan off, and it doesn't matter the setting. I'm holding my hand up here just to block the microphone a bit from the airflow. But if I turn that off again, it won't actually start because the fan was at its lowest setting, so it needs that little bit of a nudge to start. Let's see if I can block microphone here to avoid hissing noises. So even if I turn it up to its full speed setting, and then click that switch, while it's charging, it kills the fan completely. I shall turn that off now. So that's the circuitry. It's surprisingly complex. The bit that took the most to work out was those 4 diodes and the circuitry used for regulating the fan motor speed just by operating a transistor in its sort of linear region. And it is a standard NPN transistor. I've forgotten the number of that transistor. Hold on a second, just give me a second, I'll just find the number of that transistor. It was a 882P, Was it a D882? Yes, it was a D882P transistor, which is a generic NPN transistor. So there we go. It's interesting. It's actually okay. It's a very simplistic circuit, but it does charge at a consistent 100 milliamps for the, even though it's just using a capacitor, simple capacitor here. There's no overvolt protection, I guess. It's just relying on maybe charging at 100 milliamps all the time. There's no cap to what it charges this, but maybe the sealed lead acid just simmers away gently when it's left trickle charging for too long. Other things worthy of note is this housing. Initially I thought this was all bonded together, but this battery actually slips out of here. So this carrier doesn't just screw the battery down, but also has a mounting post for the circuit board, for the two mounting posts, the circuit board. And you'd have to be careful if you took this apart not to put too long a screw in here, because it could actually penetrate into the battery because it's smaller screws. But there we go. It's an interesting little unit. So I'd like to thank Vince, the crew chief, for supplying that for our entertainment. It really was quite interesting.